Hey class, it's your favorite Professor Hussein, and today we're going to go over, or this week, we're going to go over charts and such, okay, or charts, or, so we're actually going to start learning how to read things. All right, so this is going to be lesson 2.1, frequency, histograms, and distributions. This is, of course, going to be a little bit, it's not going to be as, the past several lectures and videos have been longer, and there's a lot more information. Now we're going to start moving forward a little bit faster, and it's not going to be as, you'll get what I mean. Anyway, okay, so in this lecture, we're going to go over what frequency histograms are and what relative frequency histograms are. Okay, and then we're going to look at the description of 5 different types of common distributions that you'll see in statistics. So distributions as in like how, the shape that they make in a graph. Okay, and then we're going to look at what outliers are and explain what they are, why they're there, how you get them, stuff like that. Okay, first of all, so what is a frequency histogram? Okay, so it's a very specific type of bar chart that's made from data in a frequency table. So in the next slide, we'll go over what a frequency table is. But so basically, I know you've seen these type of charts before. You might already know exactly what I'm talking about. But so basically, it's like these, these type of things. All right, where they have like some kind of constant on the bottom, and then you got the frequency up here, and there it is. All right, so we're going to look at what frequency histograms are and then relative frequency histograms, okay, in this lecture. So what is the purpose of the chart, okay, as a frequency histogram? Okay, why do we even do this? Why do we care? Well, we're going to kind of see how the whole point of doing these bar graphs is so that we can actually look at the shape, we can look at the distribution, and we can see how, see if there are any types of trends happening here. Okay, and then that will tell us something about the data, or like what's actually happening in that study. Okay. Okay, so what is a frequency histogram? Well, this is a frequency histogram, okay? I'm sorry, I'm kind of covering up some of this, but just to get the idea, basically a frequency histogram is where it tells like how many times of a certain value a certain event occurs. Let me show you. Okay, so usually what we can do, or what I usually do when I look at something like this, is I'll identify the independent variable, which is the variable that it's like a constant. Okay, it's always going to keep going, and it's going to be the exact same thing in every, it's constant. Like it could be time, it could just be categories, it could be different levels, groups. Okay, so it's that thing that you're not manipulating that. Okay, you're not trying to, it can stand alone, and okay, so all right, so the independent variable in this situation would be the class limits. Okay, so see how these are constant, each of these independent variables, all right, this section of independent variable, they're constant. Okay, each one goes up 8 miles. It's like 8 mile, 8 mile, 8 miles, 8 miles, 8 miles, 8 miles. So, it's like an 8-mile difference between every single one, right? So for the first 8 miles, what is the frequency? Like how many people were able to run 8 miles? If, let's say, if that, is what we're trying to figure out. Because the frequency would be how many people, Okay, so that's the thing that we're measuring. That's what we're trying to count or measure or evaluate, what we're trying to figure out. Okay, this is your dependent variable, and this is not a constant because this is what we're trying to measure. Okay, so that's your frequency. That's the thing that you're measuring. Okay, and then we'll get into what a relative frequency is in a little bit. All right, so right now, just always be able to identify your just your constant, okay, which is here your independent variable, and then you got your dependent variable or your frequency would be right there, okay, and that is the thing that we're trying to measure, okay. So just going off of the previous slide, so that was the first step to drawing a frequency histogram, drawing a frequency table or making your raw table. That's like just pretty much your raw data. But now we're on to the next step and drawing your actual frequency histogram. Yay! Okay, so the next step would be to draw a vertical line for your y-axis. And so I'm just going to show you guys right here. This is the y-axis, the line that goes up and down, that vertical line right there. Okay, that's your y. Okay, that's also known as the dependent, this is the dependent variable section, dependent variable, all right? So along the y-axis is where you put the frequency. You're gonna label it whatever frequency you're trying to, whatever you're graphing or charting today, in your study, you're going to, label that appropriately. But this is your frequency, okay? That's where you put that. That's your dependent variable section. So the step 3 would be to label that along your y-axis, okay? And to start, labeling the different parts to it. So if you're measuring a number of patients, along that, you're probably going to measure 1 through 30, 1 through whatever, okay? And then this group, in this example, they went 0 to 30, and they did it in intervals of 5. Okay, you can do that too. All right, so then the next step after that is you're going to go ahead and draw your horizontal line, all right, which is going to become your x-axis. This is your x-axis, right? We'll put that right there. And the x-axis is your independent variable axis, all right? Independent variable. All right, so that is going to be where you put your constant or your, the constant variable that you're sort of measuring the dependent variable against, in a way. So your independent variable can, like we said, it can be time, it can be, something that's constant where you can sort of check measurements like at each different class, each different level. In this example, we're using classes, and that is determined by how many miles an ambulance is transporting a patient. Okay, so each class is going to be, an 8-mile difference. Okay, so that is, what is written here is the different classes or the different levels of the constant variable, the independent variable. And that is what we put on the x-axis. Okay, so that's how we're going to label that. Then, for the first class or the first class in your data, now you're going to go, at this point, you're going to look back at your frequency table. Okay, and I believe the frequency table in the first class, it was a 14. Okay, that was the frequency number of patients that was being transported in the first class, the 1 through 8 class. Okay, so what you're going to do now is you're going to draw a horizontal line on 14, okay, in the 1 through 8 class. All right, then moving to the next slide. Okay, here we are. We drew that horizontal line, okay, and the 1 through 8 class. Now, the next step, okay, is we're going to draw 2 vertical lines down, all the way down, so that you make a bar. I'm sorry, my lines aren't very straight, but you get the idea. And then go ahead and repeat it for all the other classes. So you can look back at your frequency table and see what those frequency numbers were, you know, in your data, and then you can go ahead and fill this out. This is already filled out for us, so we don't necessarily have to do it, but you're going to repeat basically the same steps for every single class that you did, okay, in your study. Then you get to go ahead and color in the bars, fill them in. That's your last step. Pretty fun, huh? Okay, so in a relative frequency histogram, it's still the relative frequency is still going to go on the y-axis, okay, so it's still going to be in the same place, and your chart is still going to look similar. It's going to have a similar type of a pattern, okay, when you go ahead and go to plot it, but it is actually really good. It's a whole lot easier to compare to two populations or 2 different samples, you know, when you're studying. So if you are doing an experiment or study where you're comparing two separate populations or more, it's a whole lot easier to do a relative frequency histogram other than just your frequency histogram. Because what a relative frequency histogram is that it shows you, it's more, you're dealing in percents. Okay, so the frequency or the dependent variable, sorry, right here, we're dealing with percents now. It's not just the raw data anymore. Okay, it's proportional. So let me give you a quick example of like how you can calculate the relative frequency. Okay, so let's say just a really quick thing. Pretend that we're doing time, so 1 a.m., 2 a.m., 3 a.m. Like this could be our independent variable. These are the classes or the, you know, so whatever that constant variable that we're not necessarily measuring. And then we have our frequency, right? So whatever we're measuring, maybe we're measuring the how much liquid is, you know, evaporating from my mug of tea every hour. Okay, so, you know, let's maybe at 1 a.m. I measured it and I lost 2 inches. that's crazy. 0.2 inches. And then at 2 a.m. it was 0.3, and then at 3 a.m. it was 0.5. Why did it increase so much at that time? I don't know. But then we have our relative frequency. Okay. So your relative frequency is where you're going to divide whatever your frequency is by the sum of the total amount the total frequency amount. Okay, so if our total frequency, if we add up all the frequencies, we got 0.2, 0.3, 0.5. That's 1, right? 1. So what you're going to do to get the first relative frequency is go 0.2 divided by 1, which is 0.2. Wow, I did terrible math here. I picked terrible numbers, but anyway, you get the idea. So how you can figure out your relative frequency is where you take the frequency amount, okay, and then divide that by the total frequency. All you have to do is just add these up, and so each one you're going to divide that by the total. So divide the 0.3 by the total, divide the 0.5 by that total, and then you'll get the relative frequency, which is going to be a percentage. And then this is how you would plot it on a histogram. Okay. Okay, so kind of bringing that whole idea to closing, frequency and relative frequency histograms, you have to start with making your frequency table, okay, and then off of that frequency table, it's always good to make a relative frequency section as well, especially because you might be using it, okay. You might feel like it might be worthwhile if you include a relative frequency histogram as well in your study. May or may not, especially if you're not really comparing it against anything, but it's just good practice, okay? You know, to have that relative frequency ready to go for a histogram just in case you need it to compare it against another population or, you know, something like that. Okay, so anyway, so why do we even need these histograms? Well, like I said before at the beginning, this is going to reveal the distribution of the data, and then just going off of that, we're going to be able to tell kind of what is going on with that population. Okay, so now we are on distributions. We're going to look at different types of distributions. Okay, so first we're going to go ahead and define distribution and then figure out exactly why it's important to know what the distribution actually is. We're going to figure out what outliers are and how we can find them using histograms. Okay? So what is a distribution? It's the shape that is made when you draw a line against all of the edges in the histogram bars. Okay, so it's this. This is the distribution. Okay. So and then that can show you a little bit about, we're going to see how that can show you what is going on with the data. You can also use this. You can figure out the distribution using looking at other types of graphs as well. It's not just the histogram. So, you know, you can use a stem and leaf graph like this, and you can also watch the distribution. I don't expect you to know what stem and leaf graphs are yet, so don't worry. Okay, now let's look at the 5 main types of distributions. Now, there are so many different types of distributions, okay? There's not just 5, but these are probably the most common ones. And, you know, if we were going anything more than this, we would have to be at like a really practicing a high level of statistics, and I'm not even doing that. So obviously you guys don't need to be doing that right now. But these are some good main different types of distributions that you'll probably see, and you know, whenever you guys are doing any of your work. Okay, so now let's look at the first one we're going to look at is normal distribution. So normal distribution, it's also called mound-shaped symmetrical. Don't ask me why they call it normal distribution. They call it normal. It seems to me like it shouldn't be called normal. There's nothing really normal so much about it, but anyway. So normal distribution is when you basically see it be pretty much even on both sides and start from low, go up, peak somewhere, and then go all the way back down. Okay, usually it's symmetrical, right? So you got both sides are pretty much somewhat equal, like you could kind of fold it. Okay, so it peaks in the middle and then it's low on both sides. And I mean, we could get into a lot of examples of where you would see this. For example, well, we'll see this for a later one. Okay. All right, let's move on. So next, let me go ahead and erase this real quick. So this one is called uniform distribution. And why is it called uniform distribution? Because it's pretty much all equal. Look at that. You basically, with a uniform distribution, you don't need to make any squiggly lines. You make one straight horizontal line, and then boom, that is your distribution. Because basically, if you look at this, they're all pretty much equal. Okay, every frequency is either a 5 or a 6. All right, and there isn't much going on there. They're not, the differences between the two frequencies, the two frequency levels, they're not significant enough to even call them like a hump or anything like that. Okay, so pretty much we're going to say that these are 100% are even, and that is why we're just going to draw a straight line and call it uniform distribution. Okay, so next we're going to look at skewed, but let me erase this really quick. Okay, so skewed, go away. All right, skewed left distribution. So skewed left and skewed right distribution is where it's going to be slanted to either side. Okay, and how I want to help you guys remember the difference between skewed left and skewed right distribution is that it's going to be, when it says skewed, they're talking about the shorter side, the shorter end of the distribution. Okay, so skewed left would mean the shorter end would be on the left-hand side, okay, right here, and then it would just go up. Okay, so that's how I would remember skewed left, is it's lower on the left. And then, give me a second. Skewed right would be lower on the right side. So it starts high on the left and then goes low when it heads towards the right. Okay. Then we have bimodal, the grand finale. Whoa, we get a 2-for-1 here. Okay. So bimodal is kind of cool. It looks like a camel or something like that, if you want to think of it like that. It's where you have two humps. It peaks twice, or it just peaks more than once. Well, it peaks twice. It's bimodal. It peaks twice. So there is one question here, because sometimes it might be difficult to distinguish, when you're looking at data, because it might not be as clear as how it is here, where it's definitely, there's a large space in between the two humps. Okay, so it's definitely two humps in this situation. But sometimes you might have data that looks like this. Watch. Like this. Right? I'm gonna write them like this. And then it's like this. So there is a hump, and then suddenly you have like a little one right here, and then it's like this. So what happens when it's like that is this, would you consider this bimodal, or would you consider that normal? See, when it's like this, the gap isn't significant enough between the two humps to really consider it two different humps. So in this situation, more than likely, you would just go ahead and ignore that little space. Okay, it could be due to bias, it could be due to anything. You can figure that out later, but it might not. This situation is more than likely not going to be bimodal. It's still going to be normal distribution. Okay, the hump, or the two different humps, need to be more obvious when it's going to be bimodal. Okay, so the best way I can say you can spot a bimodal would be checking to make sure that your gap in between the humps is big enough. Okay, and what's really big enough? Well, I would say it needs to be at least one or two classes two classes in between, at least. It can't just be one and have the humps look like they're just too close, like they should be connected. So they do need to have more of a gap, at least two classes in between, I would say. Okay, so what are outliers? Outliers are data values that are very different from the other measurements in the data set. So when this happens, like for example, in this chart right here, clearly class 1, okay, the frequency in class 1 and in class 9, they're so far away from the rest of the data. They look like they're not even related. So when this kind of thing happens, you have to actually sit down and think, what could this actually mean? Because sometimes this could mean mistakes in your data. It could be due to sampling error, due to bias, but it could also be real data that could be representing the population. Okay, for example, this could actually be like a chart, a histogram of the different like weights, weight classes in people who live in this city in San Bernardino. Because you have a lot of people who are generally, fall somewhere in the middle, and then there are some people who are really overweight, so they might fall in here. And then you also have some of those people who are very underweight as well. And so it could also mean that those data readings are, that's legit data, and that is a full representation of what is going on in the population. So when you have outliers, that doesn't mean throw the data out, okay? It means sit there and think about why that might be. Try to come up with different reasons about what could be going on in the population that could have that could be representing. Is it possible to have those data readings? Okay, is it practical to have that? And also, of course, take into account what you did throughout your study. Okay, is it possible that there could have been bias? Look at any kind of sampling error, anything like that, non-random sample, anything. Okay, look at what you have going on, and then you can kind of figure out, okay, should I keep this data? Should I not keep this data? Should I just put it on the side? And we'll look at it in a little bit. What do we got to do? Okay, cumulative frequency. So how do you get your cumulative frequency? What is a cumulative frequency? So in a cumulative frequency, that is where each class sort of builds on the next one. Okay, you know how kind of like when like you're rolling a snowball, and so you have your snowball and then you add more to it when you roll it, and then you roll it again, you add more to it, and then you roll it again, you add more to it, and you just keep going until it's big and it's just like a sum of everything. That's kind of what cumulative frequency is. Okay, so how this works is you're going to start with the first class, whatever the frequency is for that one. Okay, in this case it's 14, so 14 is your starting cumulative frequency. Then what you're going to do is add that to the next class. Okay, so you take your 14, you add it to the 21, and you get 35. Then you're going to add that to the next class in the bottom. So you're going to take your 35, you're going to add it to the 11, and then you get 46. Okay, so you're going to do the same thing all the way down your frequency table until you get to the total, which is going to be the total, the sum of all of your frequencies, which is really going to, in the end, it's going to add up to the frequency, the total frequency that you already had. But this is just another way of looking at it. Okay, so the chart of the cumulative frequency. So first of all, you're probably not going to see much of this in healthcare, almost ever. Okay, so I think they use this mostly in economics. But anyway, so how do you chart your cumulative frequency? It's not going to look like a histogram at all. Okay, so what you're going to do is you take your class, which is going to be, of course, on your x-axis as always. That is your independent variable. And then your dependent variable is always going to be on your y-axis. And those are always your frequencies. Okay, so you're going to chart your cumulative frequency on the x-axis. And the cool thing about the cumulative frequencies is that it will always be going up. Because if you look at the table, that your cumulative frequency table, remember, it's always building on each other. Okay, so it can only go up. If you did it right, it's going up. All right, when you chart those numbers, they go up. All right, and they're going to make some sort of shape, and then you can kind of read it that way.